Hello guys, today we're going to look at this problem of aonecode, which is supposed to be appeared at the Amazon online assessment. And let's see. So this question is called load balancer, and I only recently tried this aonecode, and it says it has the online assessments of Amazon, so I do not get any money from them. I think it's actually a good platform. It's not as good as LeetCode. It doesn't have any discussions or such, but I think it's pretty good. So and the question is like this. Given an array containing only positive integers, return if you can pick two integers from the array which cuts the array into 3 pieces such that the sum of elements in all pieces is equal. Example 1. Input array equals 2, 4, 5, 3, 3, 9, 2, 2, 2. Output true. Explanation. Choosing the numbers 5 and 9 results in 3 pieces. 2, 4, 3, 3, and 2, 2, 2. Sum equals 6. So it means that we're just like excluding this 5 and 9. So these values of 2, 4, and 3, 3, and 2, 2, 2 sums up into 6. And we are returning true. And for the example 2, even though we pick anything, like let's say we pick this 1 and 1, it'll just going to have 1, 0, 0, 1, 0, 1, something like that. So we cannot separate this into 3 parts. So it's a false. So there might be some ways to do it, but the way we can solve this is to use two-pointer technique. As all two-pointer technique does, one pointer moves from the left, one pointer moves from the right. And we're gonna move this towards the middle until the left pointer becomes bigger than the right pointer, or equals, because we have to have like 2 separators. There's the pitfall we can fall into, but we can talk about that later. So let's do this. We're using Python 3, and we can set left pointer as left, and we can set it to 0, and we're gonna set right pointer, and we'll set the pointer into length of array -1. Please. And after this, we're gonna compute the 3 sums, the left sum, mid sum, and last sum. But so we're gonna compute it first. As in Python, there's a sum function. So let's just say first sum equals sum, and we can use the array notation, which is everything but the left. And second sum will not include the left, so we would have to do left +1, and it will also exclude the right. The third sum is going to not include the right, so it should be right +1. Yeah, and we forgot the square notation. And we're gonna do a while loop, while left is smaller than right. We're gonna do, and we're gonna do an if first sum equals second sum equals third sum, and not equals 0, because that means that we only have like 2 elements, and then we're gonna exclude that. Like, it's kind of ambiguous whether to exclude that or not, but I think this question does not require that, so we'll just put in here and return true. So now here is the problem. So when I first solved this problem, I did something like this. Like, I did first sum if first sum times 2 is smaller than second sum plus third sum, then we're gonna increase the left pointer, and else if else right minus equals 1, and after this we have to return false. So this is the first approach I have done, and it kind of makes sense because the first sum should be equal to second sum and third sum, because if it's like bigger or smaller than second sum plus third sum, it should increase, right? You can hit submit, and we don't get a good answer. So this is kind of technique we can use, but what we can do in this kind of situation, we kind of don't know what's happening, and we don't want to. We could do like test coding by hand, and it actually makes your thinking ability better. But what we can do is that we can make first sum in Python. This is a little bit cumbersome. And we can see what's happening here. And what? Oh. And we can see that it gives 0, 15, 0, 0, 15, 0. What is this doing? Oh. What? Oh, we have to do this. Inside the while loop. I'm sorry about that, guys. And still, it's not working. If you see this, it's 0, 15, 0, and because 0 is smaller than 15, it advances and comes. Oh, we have this. It comes to here, so it's 1, 12, 0 now. Still smaller, so becomes 4, 8, 0. So it's now similar to mid sum and last sum. So is this the right solution? It is actually the right solution. When the separators here and here, it should make this to move to the right. But when we see this 4, 7, 2, this is because when the separator is supposed to be 4 and 2, it's like subtracting 1 less than it should when it's actually separating here. So we cannot rely on this logic to move the two-pointer technique. And because of this, we have to apply new technique, which is not relying on the second sum, but just relying on the first sum and third sum. So what I mean by that is kind of a kind of greedy algorithm. So what we should do is when first sum is smaller than third sum, we should move the left counter. And when first sum is bigger than third sum, we should move the right counter. And what if they are equal? If they are equal and they are even equal to the second sum, it'll return here. But this means the second sum is bigger than first sum and third sum. So those two separators are not the correct separators. So we are actually safe to move it at both. So we can do this and this together without, we don't need this now. And when we submit this, ta-da, we're done. So this was a neat example of two-pointer technique. I guess you have learned something here, and this is set to come out as like one of the online assessment of Amazon. So I guess it helped you guys. Bye.